Hello learners, today we start second part of nuclear physics. In previous video, we concluded the Rutherford's result, that is the proton exists in a nucleus of an atom. Before go further, have a look on another one simulation. It's a radioactive isotope of hydrogen which converted into helium. Second example of carbon-14 radioisotope converted into nitrogen. One atom changed into another one by ejecting an electron and antineutrino from a nucleus of an atom. This is a beta decay process of radioactivity. From this, the concept of proton and electron exist in the nucleus as a constituent particle arose. This theory is known as proton-electron theory. According to this theory, the nucleus charge is equal to atomic mass number, not atomic number Z. In addition, nucleus contains A protons, A minus Z electron, which is surrounded by Z electrons outside the nucleus. Let's discuss the failure of proton-electron theory. First one is wave mechanical consideration. If electron exists in the nucleus, then delta X is equal to 10 raised to power minus 14 meter, which gives the value of delta P equal to 10 raised to power minus 19 kg meter per second. Calculated energy from these two gives the value of 200 mega electron volt, but experimentally it is equal to 2 mega electron volt to 3 mega electron volt. That means the region where electron exists is much more bigger as compared to the nucleus. Second is nuclear spin. To understand this, take an example of nitrogen nucleus, which consists 14 protons and 7 electrons with half spin. Theoretically, 21 particles give a half integral spin, but experimentally it is found that it have an integral spin. Clearly, it violates the rule that even mass have integral spin and odd mass have half integral spin. The biggest major change in this theory happened after the discovery of Chadwick in 1932. He discovered a particle which has more mass as compared to proton and had no charge. Particle is known as neutron. Then Heisenberg proposed a new hypothesis that nucleus contain proton and neutron in a nucleus. Some factors there which support proton and neutron theory of a nucleus. First is wave mechanical consideration. In wave mechanical consideration, using the mass of neutron, it gives energy equal to 10 raised to power 3 mega electron volt, which is little more than the rest mass energy of neutron, that is 938 mega electron. The assumption of nuclei built from proton and neutron satisfy the difficulty of nucleus spin. If the nucleus contains even number of nucleons, that is, it has integral spin. On the other hand, it contains odd number of nucleons, then it have half integral spin. Now we look about the various facts or features of nucleus. First one is nucleus size. As previously discussed, the first insight on this nuclear size is Rutherford's experiment, which gives the value of nearest distance approach distance, that is R0. The value of atomic number Z is equal to 79 for gold nucleus, and if we suppose alpha have energy 8 mega electron volt, then R0 value is equal to 2.29. Thus, the most powerful method to investigating the nuclear size is the scattering of electrons of high energy at different angles with various target nuclei. The second important point is nuclear radius. We assume the volume of nucleus approximately spherical, that by increasing the atomic mass number, its volume increases. That is 4 pi by 3 r cube directly proportional to A. It leaves the value R is equal to R0 a to the power 1 by 3. Whereas R0 is equal to 1.4 10 raised to power minus 15 meter. Third one is nuclear density. As we know, general formula of density is mass upon volume. After putting the values in this formula, we get the value, it is equal to 2.29 10 raised to power 17 kg meter per cube. We can say the nuclear density is independent from atomic mass number, so it is constant for all nuclei.